Here we go with the second part, or the second video for section 2.1, and we just have a few more word problems that we're going to do here. Example number 15 is yet another word problem, and it states, an object is traveling around a circle with a radius of 10 centimeters. So once again, I'm going to put my trusty diagram, and there's the information that was just given. If in 20 seconds, okay, now here there's no way to actually show this, but I am going to write it down. We go through a central angle of 1/3 of a radian. So the central angle here is 1/3 of a radian. Is swept out. What is the linear speed? Well, now the linear speed is determined by v equals s over t, where s represents the arc length. Now we can achieve that arc length pretty easy. S would equal r theta. Well, the radius is 10, and theta in this case is 1/3. So s in this case would be 10/3. T represents time, or the 20 seconds. And so we get 10/3 over 20. And when we simplify this, this will simplify to a 2. And so we get, we would end up with 1/6. 1/6 what? We're looking for a linear speed. So that would be centimeters per second. 1/6 of a centimeter per second. Very, very slow moving object. Number 16. A gear with a radius of 8 centimeters. Is turning at pi over 9 radians per second. Now this is called an angular speed because it tells us how quickly it is going through a particular angle. What is the linear speed? Well, the linear speed is determined, or is the velocity, and that is r omega. R still represents the radius, so that'd be 8. Omega represents the angular speed. Well, the angular speed in this case is pi over 9. And so multiplying here, we get 8 pi over 9, and we just need a particular label. Well, we're talking, we want the velocity, so that's going to be how much distance, centimeters, in a particular amount of time, seconds. And so our final answer becomes 8 pi over 9 centimeters per second. Example number 17. The Earth rotates about its pole once every 24 hours. Okay, so we've got 24 hours happening. The distance from the pole to a location on Earth 35 degrees north of latitude is about 3,243.8 miles. Now, what that basically means is if we take the Earth and 35 degrees, that's what we're talking about, right there at 35 degrees north latitude. This distance here, from here to here, the S, the arc length, would be 3,243.8 miles. Therefore, a location on Earth at 35 degrees north latitude is spinning on a circle of radius 3,243.8 miles, and we're computing the linear speed on the surface of the Earth. Okay, well, this was just a visual of the entire situation, but what happens then means if you are right on the 35th parallel, north parallel, then the radius would then become 3,243.8 miles. And we know we're going all the way around in 24 hours. And we want to know what is the linear speed, which is v. V equals r omega. R in this case, the radius, 3,243.8. And here we have to calculate we are going one revolution every 24 hours. And the one revolution is 2 pi. All the way around is 2 pi of a circle, or 2 pi around the circle. So we're going to go 2 pi every 24 hours. And so doing the multiplication, and we actually do get to round here because we are given that decimal point at the beginning. And so when we do this whole calculation, we end up with 849.22. 849.22 miles per hour. That's how fast we are going approximately. Although we don't really notice it because the atmosphere doesn't allow us, or it doesn't really permit this sensation. But we are traveling at approximately 850 miles per hour. And the final example is number 18. A carousel has a radius of 19 feet. And it takes 29 seconds to make one complete revolution. What is the linear speed of the carousel at its outside edge? V equals r omega. Okay, so the radius is 19 feet. We go all the way around, that's 2 pi in 29 seconds. And the problem does say, if necessary, round the answer to 2 decimal places. I don't see it necessary here. It may not be a very nice fraction, but it certainly isn't necessary because nowhere do we have decimals already. So just multiplying this out, we would get 38 pi over 29. And all that is necessary from this point is the actual label. We are looking for velocity, or the linear speed, so that would be feet per second. 38 pi over 29. Now, to give us an idea of what that would actually be, we can certainly see approximately how fast that is and get a calculation. And it's a little over 4. So 4 feet per second. That's a nice clip. It's not fast by any stretch, but 4 feet per second. I'm moving just a desk width distance every second.